Good evening, and I welcome all the participants and resource person, Dr. Kanchan Mishra, sir. As you all are aware of about the Science Dialogue series, those who are new, for them, this information is important that this Science Dialogue series is free webinar series. It's open for all. We invite speakers from different domains of biology, and they are expert and renowned in their field. So I request you all to attend complete lecture. And if you wish to take e-certificates, then you have to fill the feedback form, which I will share in this chat box after completing the lecture. So don't leave before the lecture and don't join after the lecture and then ask e-certificate. So every time I request, purpose is to increase knowledge pool, not only to popularize and to make है ना popular बनने का नहीं है. हम चाह रहे हैं कि साइंटिस्ट पॉपुलर बने, लेकिन उससे है पर्पस की नॉलेज पूल बढ़े. So don't join only for getting e-certificate, join for learning and interact with the speaker. That is purpose. You must get maximum utilization of knowledge of the speaker. In this series, today we have invited Dr. Kanchan Mishra, sir. And I will not give you a complete introduction of today's speaker because those who are old participants of the Science Dialogue series regularly attending, so they must have attended his one lecture earlier, 6th or 7th month earlier. I will add his introduction in, so you can join on LinkedIn also. But briefly, he is associate director, deputy director at Surat Raktadan Civil, Kendra and Research Center, Kendra and Research Center, Surat. And he did his PhD from SGPGI, Sanjay Gandhi Postgraduate Institute, Lucknow. And he also did his postdoc from Japan, prestigious institute. And he has several awards also. And he's also vice president, I think, of this organization, Stem Cell and Regenerative Medicine Organization. I'm not reading complete lecture, नहीं तो इनका introduction ही एक lecture हो जाएगा. So I will not give you all complete lecture. You can search if you will add his name, you will find so many award and everything. So we are lucky that he is ready to deliver lecture, second lecture in this free science webinar series. This is free. As you all know that we don't offer any honorarium to the speaker, and we also don't charge to the from the any of the participants. So I'm grateful to you, sir, for accepting our invitation and ready to deliver lecture. So now platform is yours, sir.
Thank you, Gopalji. Gopal sir, give me this opportunity to speak about the stem cell. And nowadays, era is the stem cell. So every people, not only for knowledge, for the therapeutic purpose, they must be know about the stem cell, what the stem cell, what the stem cell therapy, because coming future, generalize the medicine, not medicine, the stem cell. So I'm going to share my screen, then I will start my presentation. It's okay? I can share my...
Yes, sir. Yes, sir. Please share, sir.
Okay, can you see the window?
Yes, sir. Yes, sir.
Okay, so today I'm going to speak about the stem cell and regenerative medicine and its application and what the challenges for the clinical development. So I am just Gopal sir ne bola, I am belonging from the Surat Research Center, and this center have the very good research institute. This research institute all approved by the government of India, the DSIR. We have the NABH accreditation. We have also the department of the stem cell department for the cardiac banking. We have also the multi classes here. So in umbrella of the this center, we have the many other branches. We have the also the different research division here. So I am pleased to let you know, because earlier people know, but some people may not know. Our the center inaugurated by the Modi ji. That time he was the CM. So, so today I'm going to speak about the stem cell, what their application. So why stem cell needed? That's right. Because as we know, there are n number of incurable diseases like thalassemia, sickle cell, cancer. There are many. The moment we don't have any treatment, right? Like diabetes is we have treatment, we don't have treatment, right? So what the other option to treat this incurable disease? Yeah, how we can goodbye to this incurable disease? Even just for the example, if you go the neurological disorder like autism,
सर
about
ये हाइड कर दीजिए, वहां जो लाइन नीचे है सर,
okay,
जस्ट हाइड. यस
हाँ.
सर.
Like autism in India, like 79 lakh people. Cerebral palsy, muscular dystrophy in Surat, every month one people die due to DMD. So there are many incurable diseases we don't have any treatment, right? Even if you go the burden of osteoarthritis is the very common in the women and also the men after 15. Most of the us by the 60 or 17. You must be surprised in India only like about 4,75,000 knee replacement are performed every year. Still, knee transplant is not permanent therapy, right? Osteoarthritis occur whole of the body like spine, shoulder, hip, feet, knee. So question is this: how we can goodbye this incurable disease? So for me, I like very good quotation. Quote करता हूँ, मुझे अच्छा लगता है ये. When we cannot direct the wind, we can adjust the cell to always reach us destination. So when we're creating the roadmap for future therapy for incurable disease, the stem cell will be the one of the best uh, approach, right? And this is the one of the those new miracle drug. If we can afford, is miracle. So why regenerative medicine? Like as we know, we have the vehicle like car. They have the if your car is damaged, you can go. You can buy the body part. You can replace the all the car body part. But for the human, there is not any shop whether you can buy your organ to replace. So, but good thing in human body, in our body, we have the capacity to regenerate our organ, and this regenerative medicine have a very good capacity. This is very important because it follow the natural healing process. There is no any side effect. It can be the best option for the avoiding or delaying surgery. It offers the shorter recovery time over the surgery, right? He offered the state of the art facility for the output patient. It does not require anesthesia, right? And it enhances both activity and the range of the movement. It provides the more relief from pain and inflammation. So that's why regenerative medicine very important. As when we used to say that regenerative medicine, people say that the very new era, but regenerative medicine may not be new as we thought, right? If you know, is you go the Greek mythology, I think many years back, there are those Prometheus. He stolen the fire from the god to for the humankind. So God have given the punishment. One eagle used to come every day. The eagle eat to their liver, but again next day liver is to regenerate, right? So hepatic regeneration was well known in the ancient of the Greek era. So regenerative medicine is not concerned on new. It's very old. Even if you go the Hindu mythology, there is a lot of the regenerative medicine thing like born of the Karna was born with the stem cell. So it is not new, but I think we don't know a bit. We don't have awareness. So why regenerative medicine important? Regenerative medicine aim to develop a novel therapy that will replace or repair or promote a tissue regeneration. This is a minimal invasive, right? Other treatment that increase the blood flow, promote the cell regeneration in the injured area, right? They are not permanent therapy because treatment may be prescribed again as depend upon the situation, depend upon the age, right? So regenerative medicine not the particular one division. It's neurology, gastroenterology, cancer, vascular disease, stem cell banking, endocrinology, autoimmune, orthopedic. There are all medical branch, they have started, we have the option for the regenerative medicine, right? So for the regenerative medicine, how this occur due to stem cell, right? So today I'm going to speak about the what about the stem cell, history of the stem cell, question and unknown problem, legal consideration, and all this current status of knowledge, all the thing. So I think we must be knowing what the stem cell. I'm going to brief about the stem cell. A cell that has the ability to continuous divide and differentiate, develop into the various other kind of the cell tissue. So those stem cells they have the properties, right? So as you know, stem cell master cell, they do not have any specific function, but they can self copy himself, or they can differentiate splice cell like muscle, nerve cell, depend upon the our body needed, right? So question is, why stem cell renew and differentiate? You know, if stem cell cannot differentiate, cannot renew, so one day we can lose all the skin. So that why stem cell must be have to differentiate, like replace the dead and damaged cell through the our entire life, and the cell renewal very important to maintain the stem cell pool, right? So that's why. If you go the main, there are three types of stem cell: embryonic stem cell, adult stem cell, and induced pluripotent stem cell. You know, all our life starting from the stem cell and end to the stem cell, right? So we can question what the stem cell found. Stem cell found in the embryonic. There's a mostly from the embryonic to adult. There are three types of stem cell. Pluripotent. From pluripotent you can make the one human being, right? Pluripotent you can make the any organ, and multipotent they have the they can differentiate some specific type of the cell, right? Sorry. So about embryonic stem cell, I'm going to let's speak, because embryonic stem cell we can isolate from the blastocyte, and embryonic stem cell, they have a beautiful property. They can differentiate all possible type of the splice cell, skin, nerve, hepatic, liver, everything, cardiac. They can differentiate. So this is very important. You can see the embryonic stem cell. They can in one condition they can differentiate the skin. In other condition they can develop a neuron. In other condition they can same stem cell can make blood. Same stem cell can go under the condition D, differentiate the liver. So still we don't know what the condition, how this stem cell can make all this thing, right? So but work on the problem is that if you want to do some research as on the embryonic stem cell, is a ethical debate. In India, government they are not allowed to therapy for the embryonic stem cell, because harvesting stem cell they destroy the blastocyte. So government says this is a murder. Embryonic stem cell research required human cells, could create a commercial market for the human cells. So most of the government they had put the ban to work on the embryonic stem cell. You know, must be on August 19, 2001, British president of USA George Bush, they have the ban. They started the ban to work on the embryonic stem cell. But again, when March 9, 2009, President Barack Obama came, they can relieve the ban. So anyway, so we can speak about the stem cell. There is no any ban. So mostly adult stem cell, there are three types: cord blood derived homeopathic stem cell. Those cord blood banking used to say we have the here also cord blood bank. I think one topic we have taken the cord blood stem cell bank. Second is induced pluripotent stem cell. Third is the adult mesenchymal stem cell. Cord blood stem cell I have already given the whole lecture. In brief, I can let you know. The cord blood is the remain blood in the umbilical cord and the placenta collected after the clamp cord birth, and this after the birth this cord blood collected. The degree of the temperature must be 20-25 degrees Celsius. Then transport into our facility lab. Here we can be isolate, and we can keep this cord blood stem cell in at minus 190 degrees centigrade for longer time. Depend on the possibility. The pupil, if they want to use it 10 years, 20 years, 70 years, it's for the you can stay for the lifelong. So for the cord blood in India, still there are most of the 80 diseases that can be treated by this cord blood stem cell, both by autologous, allogenic, and corporate stem cell bank is very it is a biological insurance. Like you, if you can save the your corporate stem cell for your baby, this stem cell if any incurable disease occur, so this stem cell can definitely can cure the can cure the your baby, but it's also can help your sibling like brother, sister, even parent, mother, father, even your dada, dadi, because it's the same. We have the same HLA pooling. So why be recommend the cardboard, because it's easy to collect and no risk. There's to collect the cardboard steps that not going to harm the either mother or either baby. Or this is very important because it's a one lifetime opportunity. So the parent must keep the cardboard for their family, maybe use in the future. So now going to some about the induced pluripotent stem cells. Second time you must be known. If we say, short form we used to the IPS. If we have what the IPS, it's a reprogramming. Like अब अमिताभ बच्चन को दोबारा बेबी बना दो. So IPS means reprogramming. You know the like all the skin is the not stem cell. From the skin we can make the stem cell. This IPS, you must be all knowing in the Japan, these two scientists and Dr. Gordon and Dr. Yamanaki, he got the Nobel Prize because they discovered this induced pluripotent stem cell. So what they have, because stem cell, see, we must be knowing what the property of the stem cell, how this cell, any cell, they become the stem cell. They found they do R&D. They found there are 4 genes that's responsible for make any cell to stem cell. Then it's again cut down. They in the last they discovered that this 4 gene like OCTA4, SOX2, CAG4, and CMYC, they are responsible thing to make any cell to stem cell. So what they have then they have taken the skin cell, normal skin cell, the skin cell, the not the stem cell. They induce this they transfection this 4 gene into the skin cell. After some time, this skin then become the induced pluripotent stem cell. So by this method, you can make any cell to any time the stem cell, but they are the induced pluripotent stem cell. They have advantage, they have disadvantage also. Advantage is this is an abundant of cell of the donor. Now you can make any number of the cell, you can make the stem cell, but still it's a very costly affair. And also it's very important HLA. So HLA match, because you from the one donor to another donors to again whether HLA is going to match or not. But disadvantage is very important is increase risk of development of the cancer. Still or costly still the pupil the hope earlier we had on the IPS it's going to miracle, but still in the question mark. Still we are working. Let's see in the future we have some good option. So third is the very important stem cell, that is the adult stem cell. We know the mesenchymal stem cell. So this adult stem cell, mesenchymal stem cell, they have the very good property, and this mesenchymal stem cell you can isolate from the bone marrow, from the umbilical cord, cell umbilical cord tissue, from the adipose tissue, from the molar cell, from the amniotic fluid. There are n number of cells we can isolate this mesenchymal stem cell, right? So already there are many of research. Most of the research people have done on the bone marrow derived mesenchymal stem cell. After that, umbilical cord. Umbilical cord is good source because there's a lot of the no ethical problem. There are a lot of plenty of the source, because after born the baby we have to, because this umbilical cord is to the medical waste, we have to throw it. So n number of the source that we can isolate, or there are many good mesenchymal stem cell in umbilical tissue. So in our laboratory we have developed the method to how to isolate this mesenchymal stem from this umbilical cord tissue. So to the culture to the make the stem cell isolate from any of the source, there are 3 important function must be. That's why you can say these are the stem cell of the mesenchymal stem cell. They have the plasticity. This stem cell, they have the very good property. They can adherence. They have the homing property that they know where to go. They have travel to site of the tissue injury. or main is the endowment to unite the other tissue and enhance the anti-inflammatory and the immunosuppression. They have the property of immunosuppression, they don't have the property of HLA. So from the to take the mesenchymal stem cell from the any donor, anybody can take. It's autologous and allogenic because they don't have an HLA property, right? So why the only we are talking the mesenchymal stem cell? Because for the develop, there are decade research have the many clinical trial. People say they have already come down with the research, no risk of tumor, no oncogenesis. Like in IPS, there is a chance after make up the carcinogenic cell after the some time. No ethical issue do not have come from the embryo. Okay. Get specificity for the connective tissue and the inflammatory disease. And these mesenchymal stem cells, as I said earlier, they have the two main property, immunoprivilege property, because they don't have a HLA property. Any can take allogenic and autologous and the immunomodulatory. They can suppress the immunity also. So there are many areas where we can use this MSC for the immunosuppression. You must be knowing, surprised to know, in era of the COVID, that COVID patient they are treated by the just mesenchymal stem cell. Right. I will let you know how in the earlier slide. So, how this mesenchymal stem cell work? Cell respond to appropriate cytokine signal release from the tissue injury, the inflammation, degradation, disease are cell there, and they have the parakine mechanism because this stem cell, this MSC, they secrete various cytokines, various growth factor. These all the secret cytokine growth factor, extracellular basicule. These all biomolecule together promote cell proliferation, cyto production, immunomodulation, or angiogenesis. You know for the any regeneration, angiogenesis is very important, right? Or this stem cell, they have the good angiogenesis because MSC they secrete the vascular endothelial growth factor. This facilitates the formation of the new blood vessel. So regeneration property, the very important, they have the good angiogenesis, right? They're the must blood flow. As I told you, always safety of mesenchymal stem cell because sometimes people they have worry. Is this MSC can after some time they can carcinogenesis? Still, I got the asymmetric review conducted by the Canadian group in 2012. Found that no significant association between MSC and infusion and tumor formation because MSC is the secret growth factor cytokine. No, they help to degenerate the thing, and growth factor act on the cell surface receptor only. They do not cause the DNA mutation. So no possible mechanism by which growth factor would result in the neoplastic development. So there is no single report of this literature growth factor can cause the carcinogenesis. So there is no worry about that. So nowadays, whole world they're working on the mesenchymal stem cell. There are many clinical trials come, and they also the Japan is one of the country. They have the many FDA approved mesenchymal stem cell therapy. So for that, they make the more international law. How we can know what the criteria the people who work on the mesenchymal stem cell. So there is a criteria by the international law. This mesenchymal stem, they have the first property, they have the self-renew, right? Second, MSC must be adenoplastic. MSC must be with the special cell marker like CD34, CD90, CD105. This is the positive marker, or this is the lack of expression, some negative marker like CD45, CD34, CD14, actually DR. So also this stem cell, this MSC must be have the capacity to differentiate into osteoblast, adipocyte, and chondrocyte under the vitro condition. So these are the international property. They have to differentiate, right? So in short, we can say MSC. If you going to isolate in the lab, they have the adenoplastic. They have the must be marker expression, the positive marker. Greater than 95%, negative marker means it means there than 0 CD45 not less than 2%, right? Or there must be difference into the adipocyte or osteoblast and chondrocyte. This is the international. You can go to the history of the mesenchymal stem cell, first reported by the in 1970. Now the 2024 is going on. Till from 1997, now the scientists have done many discovery, many trial, or they develop any clinical trial for the many diseases with the help of the stem cell. So I will let you know one by one. This is our lab where we have the GLP laboratory. We have the three GLP laboratory. GLP laboratory means class 10,000, where you can isolate the stem cell other cell for the human therapeutic purpose. We have the class 10,000 where HEPA filter are there. So we have developed the isolate the from the male chemistry from the cut tissue. We have, this is the, you can see we have developed a technique. There are two type technique. This is the umbilical cord. You can isolate this mesenchymal stem cell from like two methods. There is the enzymatic method, or people using the trypsin enzyme, but and some other is the again, if you're going to use this stem cell for the therapeutic purpose, it's better don't use the trypsin. So we are using the, so here we developed the technique to isolate the mesenchymal stem cell. We have already published the paper, or we have the apply the GMP compliant facility, manufacture the GMP compliant. We have the good cryogen primary passage. It's important if you go into isolate this stem cell for the clinical application, you take the at least primary passage not more than 6 to 7 passage, because we have already done the trial, and we have done the, after 14 passage there is start the necrosis, right? We have the good reproducibility. The many popular they are using for the research purpose of the stem cell. We have the shaping condition. We used to say minus 195 degree liquid nitrogen. So also, if you going to use for the clinical application, so must be you have to see the other both tested for the cell morphology, proliferation, adherence rate, all the, and also the sterility. Very important. There is no bacteria is fungus. So we have the we have the fully automatic bacteria where we all the stem cell go by the this sterility testing. They are the negative. They also the viral testing. We have do the HIV, HBV, SCB must be they are the negative. So our all the stem cell the negative for the 3H, HIV, HBV, SCB. So these are the potency of the mesenchymal stem cell. So question is the what disease can be cured by the stem cell? I can say any disease in which there is a degeneration, they can be treated by the stem cell, right? Like the Alzheimer disease, you know, Alzheimer, Parkinson is a very common in India, also in the whole, not only India, whole world, people are suffering. This Alzheimer disease can be, because Alzheimer there is a loss of the neural cell, right? This neuron can be regenerated by the stem cell. Already in Japan they have started they have created the FDA approved the stem cell therapy for the Alzheimer and Parkinson. They have started the treated with the mesenchymal stem cell therapy for the Alzheimer Parkinson. So one day also this technique will come India. We can also treat the here India patient with this stem cell. This is the, you know, earlier I told you the osteoarthritis. Nowadays very common knee replacement, but in knee replacement is not the permanent therapy, you know. Sometime knee replacement after the 5-6 year, again you have to the knee replacement by the new. Again the knee replacement the not out the body, the foreign. So some people they cannot their body cannot allow. So but with the stem cell therapy, you know, they are the any disease they have the grade 1, 2, 3. If any patient have the grade 1, grade 2, grade 3 osteoarthritis, they can permanent cure this osteoarthritis, knee osteoarthritis by the stem cell. There is no need to for the stem cell for the knee transplant, right? So there are many papers published and already they have 100% success the knee osteoarthritis with the help of the mesenchymal stem cell. There will be low dose, not much more. There are 2 million per cell body required for to give the stem cell injection in the knee. So who must be knowing, want to know what diseases now we can treat it. The still Alzheimer disease, Parkinson disease. I told all that this disease, spinal cord injury, heart disease, severe burn, burn, diabetes, Gopal 4 disease, GBSD, GBSD very common, nowadays, because in medical we have the advanced medical facilities. So now the organ donation and organ transplant are very common in India, in other world also. So the organ transplant, like the kidney transplant, there are many people used to the kidney transplant. But after organ transplant, people they not used to die the organ after the due to this organ transplant. They used to die because this organ transplant after they pupil the patient must be lifelong for the immunosuppression. Due to immunosuppression, they acquire a lot of disease or or unfortunately they used to die. But already there's a clinical trial approved for the people who go into organ transplant. If we give the mesenchymal stem cell therapy before organ transplant and after organ transplant, there is no droppers of disease. There is no required to give the immune suppression. So it's the mesenchymal stem cell miracle. Okay, muscular sclerosis, DMD. I know in the Surat, we have the 7,000 patients here, the Surat. I think every 3 months one person is to die, but DMD they can cure by this mesenchymal stem cell. Autism also we don't have any treatment, right? The child they suffer, they cannot go to school, they cannot they can do their necessary work. The normal people they can do like go to toilet and do that brush all the thing. So autism already started treated by the mesenchymal stem cell therapy in the Bombay. There is a many hospital like I know one good doctor, Dr. Pradeep Mahajan, and Dr. also Alok Srivastava. Alok Srivastava, I think they treated more than 2,000 or 3,000 patients autism with the stem cell therapy. So here you can say by the stem cell they have this National Institute of the Biomedical. They make the human liver by the use of the stem cell. So stem cell therapy already started. Already there are many products. I will let you know in another slide what FDA approved cell therapy available in India. So is those stem cell we can regenerate the thing, but one is the problem: regenerative capacity in the body decline with the age, right? You can see the like skin regeneration when we are the child, our skin regenerate in the 40 days. When we are the 28 days, we are if increasing the age, like in the older age, our skin used to regenerate in 84 days. That's why you say that in the old people they have a lot of punch here. So the scientists try to find out what the mechanism, right? This regeneration capacity used to decline with the age, according to age. If we find out the mechanism, what the way that the people they cannot get the old age. So anyway, in India, people have to see there are 10 conditions where you can give the stem cell therapy. Like orthopedic condition, I told you, like injury, osteoarthritis, spinal cord injury, and cortical limb ischemia, DMD, autism, lysosomal storage disorder, GFD. There are multiple scores. There are heart failure. They can treat by the stem cell. There is also, the must be known the avascular necrosis, जहाँ पे हमारा हड्डी क्या बोलते हैं, इससे पेड़ सूखने लगते हैं हड्डियों में. There no supply of blood, तो हड्डियाँ is starting the necrosis. The moment we don't have a treatment, right? If ABN start, you have to replace that haddi particular hip or joint. But with if early stage like grade 1, grade 2, if patient come, they can cure by the stem cell. So you can see this in 2004 there are a number of clinical trials. You can by the year clinical trial with the stem cell decreasing day by day, year by year, right? Again this clinical trial you can say by the every year increasing the moment with the stem cell we have the many treatment by the FDA approved. There is in South Korea, Canada, New Zealand, Japan, India, Europe. The people can take this stem cell therapy and cure the diseases. You must be surprised in India. In India only we have the 6 approved stem cell therapy, right? So now I think in the whole country we have the much we have the this much in FDA approved cell therapy for the different diseases. So what the future this is the this all the cerebral palsy. Cerebral palsy still we don't have any treatment. In the future, I think one day we have the we can cure this cerebral palsy with the stem cell therapy. This is a normal development of the brain. So they are due to this type child, they are a burden their family, they are burden for the society too. But one day will we have the stem cell therapy be cured. Autism already we have the people started treating. I told you, systemic stroke again people started treat with the stem cell. Must be knowing that some people used to born this. We used to say the cleft lip disease. Child with born there is a gap. There is divide by this. There's a lip. There is no lip. Some area, but one breakthrough this discovered with the stem cell therapy. I think one in UK they have the study on the 700 babies born with this cleft platelet. They treated the stem cell. You can say cure of the this the normal lips. So it's a very surprising result. With the stem cell therapy, we can cure this diseases. So that's good thing. And also whole world, not the India popular suffering by the diabetes. This diabetes can cure by the stem cell. Already there the what first youngest child undergo the blood convert stem cell, and they cure this type 1 diabetes. And one day we have definitely very with the help of the middle common stem cell we can cure this diabetes. Even here in the my institute, we are doing research. We're going to do the clinical trial. We have already MOU the hospital. We're going to do the clinical trial to the middle common stem cell for the diabetes. You know, diabetes. Why diabetes happened? Diabetes one because diabetes is the autoimmune disorder. Our antibody they used to destroy the beta cell. Beta cell they used to secrete the insulin. When beta cell died, there are no insulin, right? But if this middle common stem cell can regenerate the beta cell, right? And again, also because this stem cell have the property immunosuppression, those antibody they used to kill the our beta cell. So this stem cell can suppress this autoantibody and regenerate get this beta cell. So we can cure this diabetes one by the middle common stem cell. So must be knowing, HIV is the stigma, right? But they're the first one woman in New York, she cured 100% cured HIV by the stem cell. Till now, in 2001, in 2019, 2022, and in 2022, till now, at the more than 5 people, they cure 100% HIV by this stem cell. So must be this is the heart the make by the stem cell in vitro. So one day we can make this heart also, because heart transplant you need heart donor. It's a very I think not possible to find out the every time the people can donate the heart. Sometime we lucky people can found. But one day we can make this heart with the stem cell, or we can the needed people we can give this stem cell transplant. In future, we can make any organ with the stem cell, or there is no need to give the organ donation. We make ear pinna, we make heart, we make liver, we can transplant in human. Definitely one day will be possible. But still there are
हेलो, मेरी आवाज आ रही है?
यस सर।
अच्छा, सर्कल लग रहा है कुछ टेक्निकल।
this stem cell you have to culture.
आपका सर वो बीच में 10 सेकंड 20 सेकंड के लिए गायब हो गया था आवाज।
अच्छा, अभी आ रहा है?
जी जी अभी आ रहा है सर। आपका फोटो भी नहीं दिख रहा था। हो सकता है इंटरनेट स्लो हुआ होगा, तो आप अपना कैमरा बंद करके कर लीजिए, अगर नहीं तो ठीक है तो रखिए। हाँ यहाँ तक ठीक है, यहाँ तक हुआ सर।
हाँ, यहाँ तक हुआ था। हाँ,
10-20
ठीक है।
सेकंड के लिए सिर्फ लैग हुआ था। यस।
ओके, तो अभी आ रहा, तो मैं यहाँ पे ये व्हाट
हाँ
व्हाट
हाँ यहाँ थे, यहाँ थे। यस।
what I wanted to let you know, people, this stem cell is a very fancy word, but still they have the challenges. The people doing the clinical trial, doing the research, what they facing the challenges, like the donor, right? Like we used to take this stem cell from the donor. So we must be take that this stem cell from a healthy donor, right? Again, because this stem cell you have to culture, so it's very important take the selection of the good every approved reagent that for the must be for the reagent they have taken the for the human application only, right? Like in the cell culture for the human application for the human transplant we are not using the FCS, right? There is a media zero free media. There is we are not that big because you know FCS there is a chance they develop the mad cow disease. So it's a very important to for the if you the people they have the stem cell lab for the therapeutic purpose they must be choose the good media that must be approved by the FDA that only for the clinical purpose. Research purpose there's a different type media, but for the clinical application there are different media. You cannot use the FCS. They are the zero free media. So benefit of the regenerative medicine, like as I told that this is a minimal invention. There no need to the like sometime osteoarthritis. There need to give the one injection in the where the osteoarthritis occurs. Like knee osteoarthritis, you have to give that injection, stem cell injection in the knee only. There no do the surgery. So most of the stem cell therapy minimal invention. Or again, this stem cell can be performed as a adjuvant to surgery, enhance the outcome. There are some surgery already have like the when baby is born, when there is a stitch mark in a mother. If you inject the milk calcium there is a reduce the stitch mark. So this stem cell stand alone as some or the some other application. The patient can take the treatment. So benefit. I can say one thing. What result can patient because some people they say that stem cell miracle. You can give the stem cell therapy today, tomorrow they will be okay. No, stem cell therapy is a regenerative medicine. Right? It's not the like a steroid is not like the painkiller. Patient will not experience immediate pain relief like if you go the mesenchymal stem cell therapy for the osteoarthritis pain osteoarthritis disease. It will take the more than 15 days because they used to regenerate. They can regenerate cartilage, right? It will take time. So unlike steroid injection, it take the time for the stem cell promote the growth and promote the repair. Take time, right? So, but the stem cell therapy result is longer for the many period. So also that's very important. After a few big patients should be able to resume their regular work activity. Like for the if you go the stem cell therapy, osteoarthritis, other people can take after 1 to 2 days they can start the normal work. So, but it's also the stem cell therapy is sometimes is a personalized therapy. It depends on some people take benefit in the 15 days, some people take the 6 months. Depend on the patient, their capacity. Every patient they have the different type of body. So I can say the take home message from here. Biological treatment offer another alternative to our standard management option. Unlimited source of the stem cell from the biological waste, right? Collection of stem cell risk free, though no need to worry about that. While the literature is sometimes not always the robust, but there is enough evidence to support use of this clinical application. These are some of my recent publication on regenerative medicine and stem cell. This is the our uh, stem cell laboratory. This is the class 10,000. We have the good facility, liquid nitrogen storage. We have the very big tank. You can be whether we can put the stem cell more thousand, 2 to 3,000 sample without the laboratory. Thank you. If people have any question, I will happy to answer.
Thank you, sir. Thank you very much. Now, attendees may ask question